Hi, and welcome to the Deep Dives Weekly podcast. My name is Johannes and I'm an instructor for Deep Dives and mostly development, analytics, machine learning, etc. And with me, I have Mikko with a similar kind of background and a just-in-time type of showing up.
Barely.
Yeah.
Sorry about
Our
that.
topic for this week was security. First of all, apologies that we didn't have a podcast last week. We met some scheduling problems, so it just was not feasible. And due to the holiday season, midterms and stuff going on. But yeah, the security topic this week comes from two reasons. One is selfish. I've just happened to teach quite a bunch of security-related courses, and I've taken some security-related certification exams as well. So the topic is kind of hot on my mind. But there's also a better reason, as we've been talking about DevOps a bit and different parts of DevOps. And we could also take a look at security from that point of view, from the software development lifecycle. But that's kind of the idea. And but we're not going to be talking about computer security, but rather cloud security. And why is that? Well, it is because cloud computing security is inherently different from traditional computing security. And this is maybe better seen, maybe we're going to have a session sometimes on migrations and on finances, cloud finances or costs. So then we can maybe go even deeper into that. But in a principle, in the traditional world where we have servers running, I don't know, even in our office, right? We might have printer servers or something like that running in our office, or in an on-prem data center. The way that we do security is via perimeter security, right? So, in the cloud, we don't do that. How come? Mikko, do you know what I mean by perimeter security?
Perimeter security?
Yeah,
like
not
in this
physically.
In this context?
Yeah.
So you're saying that the printer is being handled differently than our cloud operations?
Yes. Right? Yes.
So just how is the printer security then handled? Let's start with that.
Like any office server security, even a file server. How is our office network security handled?
Well, poorly. Just to start with, poorly.
Yeah, well, our office, yes, but in general, it is via perimeter security, right? So we have kind of our office, which is inside the perimeter.
Yeah, everything happens inside the office, and there's no access from the outside.
Yeah, or so if there is
at least there shouldn't be.
Yeah, if there is access, like a single access point, and then we have like firewall or whatever security appliance there that is controlling that security, right? That's what we mean, right? And we know that works because we know that physically the only way to connect the network is via that one point, right? It's like there are no other ways.
Do you mean network as in like internet?
To the office network. The only way to get from or to the office network is via that one point physically. We can follow the cables, right? And they all lead to that one place. And there's no other way to go around. So that's why we can implement our security there.
Almost like that. I remember it. Just I don't want to cancel what you just said, or ignore what you said. But I remember there was a problem a long time ago that you were not in one particular bank that you were not allowed to take your laptop into the premises and plug it in because there were some viruses or Trojans or something were running wild and they were getting access by you bringing physically something into the network without, well, to the intranetwork.
Yeah, exactly. Yeah. Of course,
So
nowadays with also with Wi-Fi, it's a little bit more complicated.
yeah,
The
VPN and
principle.
yeah. But okay, don't
so
get
that's how we do
distracted
it.
by my words here.
Yeah, that's how we do it traditionally. But that can't work in the cloud, right? Like literally, we don't know where our virtual machines are running on
So
what hardware.
actually, you cannot take your device to the cloud because you have no idea where that physically that cloud is.
Yeah. So the way network security works in the cloud is via isolation, right? So we're creating what is most often called a virtual private cloud within the cloud provider's environment. And we're creating a virtual network inside that. And this is something that is fairly well known, even with data centers, right? So if you lease some space from a data center and you have your equipment in different racks, that doesn't mean that your equipment can talk to all of the other clouds, right? So then what we're creating is a VNet on that, and there are standards for doing that, TCP IP extensions. But in the cloud, that doesn't really work because there's a limited amount of IDs to be used with that technology. And then we're still kind of routing on the physical network. It's just that the network streams are isolated from each other. So
you're using same cables, same physical cables as someone else.
Exactly, and that might be problematic for some people. So
from legislation point of view, for example.
Yeah,
maybe,
or just for being a little bit paranoid. It's always good to be paranoid.
Yeah, like paranoid or healthy paranoid.
Yeah, there's a fine line. Yeah. But how does this networking then work in the cloud?
That's the question you're here to answer. But as before we dive deeper in there, if this is a really good way of handling things, what you're going to reveal us soon, why we are not doing it in our office network as well?
Yeah, we are. So we can talk about that. But yeah.
Okay. So it's not that different then.
No. So what
maybe the technical solution is different.
Yeah. So because of a couple of things in the network. So first of all, the cloud internal network needs to be highly available, right? So we need to have multiple connections to each physical machine. We need to have multiple routers. Like, to simplify things a little bit, think that there's a router on the top of every rack that handles the connectivity for that. So there need to be two of those. Then the racks need to be connected to each other with high-speed bandwidth. And then whatever availability zones we might have or other things we might have in the cloud provider, those also need to be connected to each other.
And I'm by the way, I'm here to ask these new big questions and all that. Network is one of the areas where I do not shine, one of the few areas. And so when you're connecting the racks together, there's also probably a way of doing that efficiently, because you're not going to connect if you have 100 racks. They are not connected to each other, like one rack to all 100.
So traditional networks, when we're using TCP/IP, we're doing hierarchical networking.
So there's a router of all routers at the top or something like that.
Yeah, that's like the internet, I guess, or something, right?
Yeah,
So it's like there are subnets of network that then are physically co-located, and then kind of the top of the rack router knows which subnets belong to that rack, and then if it finds an IP address that needs to go somewhere else, it just throws it onwards to the next router in the chain.
Mm-hmm.
Now, this works perfectly in a highly distributed environment like the internet, or maybe even in a local area, like in a small office. However, there are a couple of problems here. So first of all, we're having highly available connectivity. So we're having 2 connections between each piece of hardware at the minimum. However, with TCP/IP, when we send basically let's say a stream of data, we can only use one of those routes. We can't use both simultaneously. That's a limitation of the protocol. Another thing is that actually these top of the rack routers are more highly available and more efficient if they would be mesh network. If they would be like at least to some level totally interconnected, so that we have multiple routes that a packet can take, kind of depending on what the traffic situation is, right? So again, TCP/IP doesn't really allow for that, but at least not very easily. So what has happened is that pretty much all of the cloud providers have created their own custom network stack.
So, and to be specific, it means that internally it's something else than TCP/IP.
Yeah, and that gives us a lot
below
of
the
benefits.
surface, and that's really confusing when you hear it for the first time. That actually, when you're sending TCP/IP packets or your software or your operating system or whatever is sending packets, then something else actually happens there.
Yep.
It's like literally everything is virtual, even the network.
Yeah,
or at least it's abstracted away the technical implementation.
Yeah, the only reason why we're sending TCP/IP packets from our virtual machine in the cloud is because that's what our operating system and software is used to do. It's not efficient, but it's easier to migrate.
It was efficient in certain kinds of environments, or probably if it was invented or reinvented or re-implemented, not re-implemented, but redone, it would be done differently nowadays, probably.
Yeah, exactly. So we need to have this. We are in this situation where we need to have this custom network stack that will run on the physical hardware. That then, because custom, we can create multiple isolated virtual networks onto it, and we can do stuff like automatically encrypt data on it, right? So that it doesn't really matter that data is running on the same physical wire than neighbors, because besides being logically isolated, it is also encrypted.
So how do we know it's actually encrypted?
We
don't see it, so it's their word against ours. Or sorry, come again.
We read through the audit reports.
Yep.
Right.
And that's one of the things that you have to trust your cloud provider.
Yeah, they use audits. So you have these third-party companies that could then come to the actual physical environment and then write how it has been implemented and then put a stamp on that. And then that basically means that a third party has seen it and that it works in the way that it has been described.
So you actually don't have to just trust their word. You can. There are third-party audits that and parties that do that.
Now the problem kind of becomes that we have this marvelous network that gives us all kinds of features that would be really nice to use. But then our software and our operating system still wants to talk TCP/IP or Ethernet, actually, which is even worse, like the hardware protocols. So what do we do? Well, we need to have some kind of a virtualization environment, some kind of a layer that pretends to the operating system that it is a TCP/IP network, and then does whatever is needed to be done to make it work on the actual network. So we're kind of doing an overlay TCP/IP network on top of that other custom network stack. And there are lots of things that really don't make any sense in like traditional Ethernet. Like, for example, an ARP call, right? So when you when your computer first wants to talk to another computer, another IP address, maybe in the same subnet. What it does, it sends an ARP request out. It asks for the MAC address, the hardware address for this specific TCP/IP address, and that is a broadcast over the whole subnet, right? And then if that IP address is on the same subnet, it will return back like, "Hello, it's me. My MAC address is this and this and this," and then they can talk to each other on the hardware layer using those MAC addresses. Now, this doesn't make any sense in the cloud, because another virtual machine that is on the same subnet than your first virtual machine might actually be located in a physically different data center, even though they have adjacent IP addresses. So the whole idea of sending kind of a local broadcast, "Please tell me if you're here," doesn't make any sense in this context. So what do? Well, we don't really need the hardware address anymore. Kind of our operating system needs it, but we don't need it for the actual communication on our layer. So then we just make up these MAC addresses consistently, of course, right? Because that's what our operating system is expecting. So we're doing all kinds of tips and tricks to make sure that the actual networking is working correctly, but then we're taking kind of shortcuts whenever possible. And now this is where it gets interesting. So think of, even if it's not true, think of the actual physical network of being this kind of a mesh network where kind of all racks or all subsections of the local network are interconnected with each other. Now, where do we put the firewall?
Good question.
Right? Where can we put it?
Yeah.
There is no single point of entry, right? There is one single point of entry, but it is per virtual machine. And that's the virtualization layer, right?
So the firewall would also be a virtual firewall.
Yeah, so
right?
kind of from one point of view, how to do network security in the cloud is you do these per instance, per virtual machine firewalls that kind of call different things in different, like in AWS security groups. And then they get evaluated. Again, we're in this situation. Anyway, so I was saying, you hear me okay?
Yeah.
So I was saying, so the one option is to do it there where we are moving from the TCP/IP world into this magic world, right? All of the traffic has to go through there, so we can do something there. And this would be kind of similar to having operating system firewalls in your traditional environments. You often do that. But then this kind of network-wide firewall, kind of the physical firewall that we put next to the router that goes to the internet, that doesn't really exist. But as it happens, we don't really need that. Because what we can say is, because this is not TCP/IP anymore, what we can say is we can just define what kind of traffic we want to have and what not. And then we let the network take care of that security, right? So this is what we would implement using stuff like maybe NACLs or firewalls in Google VPC firewall rules. They're actually evaluated on the network level, right? So once the traffic goes to some point where it needs to decide where to go next, it gets evaluated whether it should be allowed or not, and then it's taken care of. So we have basically
it's kind of a distributed firewall.
Exactly. And that's great because that means that there are no bottlenecks. There is no latency added by at least simple sets of firewall rules.
And or a single point of failure from like a physical firewall that breaks, then that's a huge problem.
And then we have the third thing with regards to network security. That has to do with the principle of minimizing the attack area, basically. So what are we doing in cloud if we're running our application and we have different amounts of requirements depending on the time of day? So we scale up and down.
Scaling.
So how can we ensure that the end customer kind of gets the correct EC2 or to the correct virtual machine, independent of how many copies there are available?
How to get to a specific virtual machine?
We have maybe between 2 and 10 machines. So how does the customer need to try out different IP addresses to find the machine that is ready?
We have some sort of load balancer there in front, or
right. And are we running that load balancer ourselves?
Hopefully not. It's
right.
From my point of view, again, I prefer simple solutions, and if there's a service provided by someone else, then by all means use that.
Exactly. So now again, the different cloud providers have different implementations of load balancers. Some of them are host-based, so they're basically a virtual machine that is running and then doing the load balancing. Some of them are actually the network itself, similarly to the security part. So we just tell the network that if somebody wants to connect to that, then divide it over the different targets in the target group. But the main thing here is that we are not the first line of defense anymore. Right? We are not the party that terminates the TCP/IP request that comes from the internet. It's somebody else. It's the cloud provider. And then that way, we automatically get rid of any kind of, lower than layer 7 attack vectors, because they're not attacking our system, right? If you have like an application load balancer, a layer 7 load balancer, that terminates the HTTPS session on its own, and then make a separate request to your backend, then there is no, weird traffic coming to our instances. We could keep all of our ports open, basically, in our instances, because we know that, no weird traffic.
But you shouldn't.
Of course we don't.
Yeah.
We're using multiple layers of security. So when moving,
So basically, you're pushing the point where most of the attacks get blocked further and further away from you. So it happens earlier and earlier, and it actually happens even earlier than that. It can happen somewhere. Let's say you're running a service in Germany. You're like the data center is somewhere in Germany. That much you know.
That is called
the services are running there.
It's called the data center in German.
Data center. So there, somewhere there, and you have that network security. You have load balancers. You have all that in Germany. But if you're the person or the system that is attacking you or making weird requests is coming from United States, it could be blocked in United States, which you wouldn't have that on the kind of a traditional on-prem system. You would have to take care of that as well. So there are a lot of things that can happen before the data or the request even enters the data center.
Yeah. So what is kind of funny here is, again, this differs a bit between the different cloud providers, but in Google, any public IP address that you get is actually an any-cost IP address. So it will be automatically routed onto the Google network at the closest point as possible from the client's point of view. And because it's then on the Google network, Google will, of course, analyze the traffic and then block it.
It's in their interest to block, for example, DDoS attacks as early as possible.
Exactly.
Not in Germany, but in the United States if the attack is coming.
Yeah. Why take bother of taking that traffic on your network?
Yeah. It's just
used up for someone else.
It costs money to move data. So
network security is kind of one thing, and I don't want to go too deep into that. We've kind of gone deep, I think, deep enough. And kind of the takeaway is that actually network security, when moving from on-prem into the cloud, it becomes more simple to handle, and it becomes more secure. We are using ready-made products that are handled by true security professionals that are working for the cloud providers, instead of Mike, who comes by two times a week to fiddle around with our. No worries, Mike. You're okay.
Runs updates and goes home.
Yeah, right. So there's a big difference here. So it's less admin cycles for us, so we can concentrate on doing whatever we're doing best. And then there's more security, right?
And before you continue, I just have to say that even it's easier, it's more robust, but you still can make mistakes if you misconfigure your network.
Of course.
So you cannot get away from that. There's always a possibility that you or your colleague, probably your colleague, makes a mistake and opens the network, let's say port 22, and which probably shouldn't be open nowadays anyway.
Yeah. That actually brings us then to so network security in general is what is called a prescriptive control. So we are a little bit like when we are giving permissions to people, we are in advance saying what is allowed and what is not allowed. And of course, we want to do as much security using prescriptive security as possible, but we can't do all of it, right? The most secure thing for our application that we are running, the most secure thing that we can do is shut it down. Right? That way, nobody can get access to it. There's no security risk.
A bit radical, though.
Yeah, but it's not what we're looking for, right?
If you don't want anyone to access your database, then shut down your database.
Yeah, but that's not often possible, right? So we need to make compromises. So with addition to prescriptive controls, we should also always apply detective controls. And detective controls, as their name maybe suggests, means that if a security incident happens, then that we get to know about it, and maybe we know how to handle that. There are different kinds of systems available for that. And in your example, where somebody would by accident open up the network, we have multiple lines of defense against that, right? So let's presume that they're using an infrastructure as code system, right? As they should. So then in that case, we probably have a static code test in the CI/CD pipeline that will scan for non-allowed things in the network configuration. So we could get it there already before it goes into production. We could test the network, so we could create a separate network with that configuration, and then run some local tests in that before making that change into production. And then once it is actually in production, we can then have different kinds of detective controls running in there that are then letting us know about these kinds of things, like opening up port 22. Like I think all of the cloud providers have a free security solution that will alert you that you have port 22 open in your
or even automatically block it if it gets opened.
Well, maybe you can automate it. Yes, definitely.
Certain things probably are good to, if you can, and some things like this would happen, then why not automate that? The remediation.
That's kind of the DevOps view, right? We want to automate everything in DevOps, and then sometimes we call this part of security DevSecOps. And I think it's always okay. We can't, use huge amounts of time to create automation for every possible scenario.
Of course not. Yeah.
But if we find a security incident and then we mitigate it, we should then create an automation for it so that the next time the same,
or at least document what you did so that next time you do it again,
but then you can just as well automate it. right?
Mm.
Write in a
Yeah,
document of what
if
you
it's
need.
yeah,
The
yeah.
same thing as writing a Lambda function or something that does that. So just do it. Just have an automation in place. And then next time it will work automatically. So you can
Actually,
always
a colleague of mine said it's okay to do it manually twice, but the third time should be you should do it after the second time. You should automate it, and then the third time it comes, then it's automated.
Yeah, I'm a little bit more strict. I think one time is enough.
But to be realistic, there are so many things that are really hard to automate. Some things are just too many variables there. The situations are similar but not the same, and it makes no sense to automate all of them.
Yeah. So that one of those things that are difficult to automate is application security. So with application security, what we mean is basically the runtime environment that your application is running in. And it consists of multiple layers, right? So there's the operating system itself that is running there, any kind of user accounts that are on that operating system. Then we have the application stack, right? So maybe some SDK, Java SDK, maybe an application server, Tomcat is running there. Those might have vulnerabilities in them. Then it's the libraries that your application is using. Famously, the log was
Open source libraries.
The logging library for Java was Log4j. Yeah, that was a big thing a couple of years ago. And then finally, it's your own code, right? But if you take a look at a kind of a modern web application, specifically if it's a microservice, then the amount of lines of code that are written by you out of the whole stack is minimal.
It's very small. It's like ridiculously small.
Yeah. So we can actually get pretty good coverage by just concentrating on the code that is actually not even written by you, right? So we can automate that. We can do that using different kinds of maybe CVE scanners that look for commonly known vulnerabilities, and then compare the version number of whatever thing you have in your system with the well-known database of vulnerabilities. And we can do this in multiple phases of our lifecycle, right? So we can do that already during build time. Just check all of the versions of the different libraries that you use against that database. Make sure that there are no vulnerabilities that are known. And then the good part is that those will also tell you how to mitigate the vulnerability. So what to do to make it go away. And then build the software. But we need to remember to keep scanning afterwards, because a version of a library might not have had any known vulnerabilities when you built the software, but maybe next week a new vulnerability came out against that specific version. So then we need to get alerted about that.
And there's actually the challenge with dependencies is that even though you think you're using version from, let's say, version 1.1, but then through some other means you end up using a different version. That can be that can be really tricky to trace. If, for example, if you don't have access to the production environment, and usually you shouldn't have. If you're like a regular developer, you shouldn't be handling the production environment, and that can be a problem as well. But so you really need to be scanning the final product and the final version when it's running or when it's in the environment that is
put in place
close to the production.
Put in place things like, of course, always pin your dependencies to a specific version. Then you know what has been used.
Then you know at the build time, but when you're actually using the software, it could be that the operating system is pushing something else, and that can be really complex.
No automatic updates. Everything needs to be done manually.
Yes, but it gets so complicated in the production. There could be something else happening in production that just overrides some dependencies without you even realizing that. So, but let's not go in there. I just know for a fact that it gets super complicated.
Yeah, it's like
Not very often, but sometimes it gets. But yeah,
so
definitely you should pin the versions that you're using, because somebody could the open source library, somebody could take over that and write on purpose some sneaky things there. Next time you update, you get the newest version, and then voila, there's a backdoor to your system.
Yeah,
that has
have
happened.
your own repo with the approved versions of the dependencies. Don't depend on a third-party repo. So you can have like a process in place where somebody goes through updating versions and then mirrors them in your own repo. That's also good for kind of build time errors, right? So if maybe the third-party repo is down when you want to run a build, and that you can't do it. That's also not good.
Yeah, just running because okay, Johannes dropped again, but I'm laughing because it's so fun to try to build a production version of your or a version of your application, and then it's the libraries are not available. This has happened before to me as well.
It's really tricky today.
You don't want to talk with me or something else?
Probably I don't. It's me that doesn't want to talk to you. But anyway, so that's sometimes called the supply chain security. So by supply chain, it means basically what we are depending on, what our suppliers are.
The dependency maintenance or maintaining the correct versions and your own repos, and that actually that's overhead.
Yeah,
and not all companies or organizations can afford that.
Yep, but it gains the security posture.
If you have a small operation, then probably you don't want to implement everything by yourself.
Yeah, and then that kind of brings us to the rest of the kind of software development lifecycle. So how does security then be involved? We already talked about the CI/CD pipeline a bit. Of course, test coverages are important here. But I think the most important thing to take away from the whole idea of dev-DevOps is a kind of a attitude change. So in the security part of the IT industry, very often the kind of attitude is to say no, right? To deny. It's like, can I install this cool piece of software onto my laptop? No, you can't. We haven't approved it, so you can't. And what does that actually mean from an organizational point of view? Well, it means that what are we doing? I'll be installing that software into my personal, and then I'll be working with my personal laptop, which is then totally out of reach for the security department. Similarly, if you would want to use a specific library, as part of your application or something else. So kind of the security people or department or function, instead of being totally concentrated on the absolute security of the organization, should see themselves as an enabler, right? So come to us and we will tell you how you can do what you want to do in a secure way, because we have the know-how. So if we can make that change, so that security people, instead of saying no, say, well, this is the way you can do it. Like maybe not the way you thought, but there's another way that is that okay for you. Like there's this other software which is has better support, whatever you can then use instead of that.
Sometimes it's difficult if you come from a small operation where basically you can do almost anything with your let's say laptop. If you go to work for example a bank, and then suddenly they have tens of thousands of people whose laptop they need to control, and so I understand that it's very difficult just to allow everything. Or it would be stupid, because then
Yeah, of course you can't do
you're
that
looking for
either.
trouble. So that rigid way of looking at things kind of works, but it could be much better. as you said, they should be enablers and not just denying every request that you have.
Right. Because very often, if they're denying, then they're breaking on velocity, which is one of the key points that we want to or key metrics that we want to maximize.
But they probably are not looking at the same metrics themselves.
Yeah, they're not. That's the problem. And then another thing that happens is that then they get circumvented. That people will do it anyway, but then we're losing visibility over what is going on. So that's not good either. So if possible, there should be a way to, via discussion, get to the correct endpoint. So that's also very important. And then there are always ways to do things, like containerization, for example. This is just because I've just taken the CKS exam. Like doing creating something like a gvisor environment, where you can explicitly select which kernel calls are available to a container and which kernel calls are not. You can literally say that any kernel call that will write to a file is not available there. It doesn't matter how the volume mounts have been configured, what the software tries to do. It just, it will not be able to write to a file from that environment, which is something that it's a little bit heavy. So we wouldn't want to do that maybe for everything that we're running. But if we are in the need of, using something that is a little bit we're unsure about, then just constraining it into a kind of a smaller, isolated place might be the good play to make things work in at least some way. So that's kind of also there seems to be always some way of getting there. And then what security people need to do is instead of just saying no, they need to go and look at the modern tools and then figure that way out, and then help the team to get where they want to get. That's kind of at least my generic takeaway. A lot of things regarding security originally had to do about trust. I remember even when I started as an AWS instructor, like 6 years ago now, it's a long time. I remember customers not being interested in moving into the cloud because they would doubt the security posture. That we can't do that. We think that we are secure if we have the keys to the data center. And then if we are in somebody else's data center, then we are not secure. And a lot of this has had to do with basic misconceptions about how things really work. And that's why it's always been very important to lecture these people, to tell them that in reality, this thing running in the cloud is going to be more secure than your current environment. Most likely, you get more security per dollar that you're spending on.
I can so feel the not invented here attitude here, that no, we cannot trust the cloud because we didn't do it ourselves and we know how to do things. And the fact is probably that you're not doing it as well as it's done in the cloud.
There's that, or then there's like this dependency on, let's just say, for example, Checkpoint software. So Checkpoint software is a firewall device manufacturer. Right? So they have invested into Checkpoint. They've bought their hardware for their on-prem, and they all of the know-how. They have taken courses and whatever, and now they're in the cloud. And then they're like, "Where do I put my Checkpoint firewall?" Like, you don't do that. I'm like, "No, I can't go there. I have to use my Checkpoint firewall." Right? So it's like there are these obstacles that are really not obstacles, that are just kind of in people's minds because they don't understand that things work in a different way. And that's kind of one of the reasons why I wanted this topic to be discussed today. That maybe we get a little bit more awareness about things not really being the same. It's comparing apples and oranges, really. So finally, I wanted to share a couple of links. I will put these in the description of the video. So if you're interested in this idea, there is an IBM website for cloud security. This is a bit of an oddball, as we normally don't talk about the IBM cloud at all. It's a fairly minor player in the game, but they have some very good documentation. And their documentation is often not specifically IBM minded. So there was a fairly good overview over, what cloud security specifically is on this IBM website, including stuff like cost of a data breach and kind of how to motivate yourself for actually paying for security services. Then I took the basic security web pages of each of the big cloud providers, starting off with AWS. So they have a fairly nice overview over the different security features that AWS infrastructure gives to you, and then the different kinds of mitigation processes that are available. So that's fairly nice. That there's like so much. This is crazy. We're teaching a 3-day security engineering on AWS course where we don't even go over all of this. We have a similar webpage for Microsoft Azure. Fairly good, I think, but very opinionated to the Microsoft offering itself. So that's why I wanted to put the IBM one there in the very beginning. With Microsoft, remember that or Azure, remember that all of the Microsoft Learn content is freely available on the Microsoft website. So if you're interested, you can go see all of the possible courses that have to do with security over there. And then finally, I have Google's security. Google is the smallest of the 3 big hyperscalers. So they often do things in a bit different way. And they were very early on with the security mindedness. So kind of, in my personal opinion, Google and AWS are the 2 kind of most secure environments where they actually designed all of the products with a security first mindset, but their implementation is very different. So in AWS, because it's a little bit older, quite a lot of the functionalities are virtual machine based, whereas with Google, more of it is actually running on the network itself. And this is partially due to the fact that the Google network is originally made by Google for Google running Google search, ads, Gmail, YouTube, all of that stuff. So they had to think about security already then, and that's kind of seen in some of the features here as well. But yeah, and then of course, if you have any questions regarding cloud security, please don't hesitate to contact us. Use the chat on whatever platform you're looking at this stuff, or get over to our website, deepdives-eu. Hopefully it's published properly by the time that you're listening to this, and send us a quick note. Note that we might be using your question in one of the future episodes content. So that's kind of what I was thinking of with regards to security. Mikko, did you have something to add? Did you tell any jokes while I was disconnected?
Jokes? No, I never do that. I was wondering about just one more thing about the security. When we were talking, just briefly mentioned about the DevOps and the automated tools that help you figure out if you, for example, are using correct versions or incorrect versions of your dependencies. But from your software point of view, like the software that you write, it's really important to use those static or more dynamic code analysis tools, because not only they find the problems that you have, but they will always they will also encourage you to write better code, which makes in the long run you will not make the same mistakes too many times, because you realize that, okay, this problem, the static or dynamic checker always finds about this, so I will eventually start to write it in a different way, in a correct way.
Good example here is
actually helped me a lot in the past when writing Java code, and when we started using let's say SonarQube or something like that, then you end up writing much better code. Even if the static code analysis tool is not running, you're writing better code. And from the security point of view, that's the same thing. If you're making same security related mistakes again and again, and nobody points it out, then you're not going to change your habits.
Yeah. I'm just trying to find the screenshot from Code Guru, which is an Amazon offering for this. It currently supports Python and Java, and it is trained on Amazon's own software kind of version repository, code repository. And it does these findings. It also does profiling, which is nice. And you can, of course, attach this into your CI/CD pipeline. So it would be, maybe even the peer reviewer would be kind of automatic. And it has pretty good things that it does. Let me just kind of try to zoom in a bit so that you can see. So it found some code where we're adding a set of skills. And this is Alexa stuff. So a set of skills to the output. And this, if this variable enabled skills here is writable by the end user. So if it's some kind of, there's some kind of a post that sets something into this variable, and then this goes back to the end user, then we need to HTML escape it, make sure that there is no JavaScript injection happening in this particular thing. So this is something that at least for me is very easy to overlook. That if there is maybe the enabled skills comes from a database, but maybe it was a free text field that somebody else was able to write into that database. And then if a different user reads it and it includes some JavaScript code, then we're gone, right? So of course, there are other places to find this in. You could do this using cross-site scripting, attack detection in the API gateway or somewhere like that. But it's always best to do this with static code analysis anyway. And I think this will become more and more, so as we have the large language models now, if we start to get specialized models for code, then this kind of stuff might become better and better over time. So
this is really painful to fix if you have hundreds of thousands of lines of code, and as an afterthought, you inherit some legacy code, and it's really big job to fix. But once it's fixed, then every single notification that comes from a tool like this will really stand out, and then it's really easy to maintain that high quality, because you just have to fix one thing at a time instead of thousands of things at the same time. But I have found these tools really helpful, and it increases the quality of the code and the security of the code as well, because not only quality but the security as well.
Yep.
You're trying to go away again.
Yeah, it's crazy.
Should we call it a day?
I think we have to, right? Something to do with the network here. We bought a nice Cisco Wi-Fi router, a pretty old one, but like a and now we're using a
Some
different
network
Wi-Fi.
security issues there.
It's not security. There's something going on the network. It's funny. I'm going to take a look at that next.
Good luck.
Anyway, hey, thanks a lot, Mikko, for being here
My
with
pleasure.
me and for enduring my connectivity issues. I'm really sorry about that. And thanks a lot to anybody who's been viewing us. Send us some ideas on topics that you want to get handled. Then otherwise, we're going to be back next Saturday at noon UTC, 1 o'clock CET, 2 o'clock Eastern European time. The sun is shining. It's nice, isn't it?
Yeah, you need to get some window blinds.
I
It affects
haven't,
the picture quality a bit. The
maybe
light is
we
not
should-
uniform. I don't like it.
maybe we should have this at a different time because this is noon, so it just kind of goes over right here.
Maybe 1
Otherwise,
hour
we need
later.
to use an external light, and that's not so good. But yeah, cool. Thanks for everybody for listening, and see you next time.
All right.
Similarly, for you, Mikko, you are now ready to return to your weekend activities.
Yes. Back to kids.
Right. Yeah. Till next week. Bye.
Okay. Bye-bye.